Okay. So, good morning, students. Am I audible? Is the screen visible?
Yes, ma'am.
Okay, thank you. Is the screen visible to you? No? Now, please reply. Is the screen visible to you? Am I audible? Okay. So, students, in the last lecture, you have studied about construction of body plot or body diagram. Okay. So, just revising within 5 minutes, I will take the remaining part of body plot. That is nothing but stability related part is remaining. Okay. So, within 5 to 10 minutes, I am going to revise the basics of body plot. Okay. So, students are joining. So, meanwhile, we'll revise the content you have studied in last lecture. Okay. So, very first is nothing but student, you have studied the basics of body plot. Okay. So, while drawing body plot, you have to remember only this table, right? So, this table is nothing but related to constant, 0 at origin, then n zeros, n number of zeros at origin, then pole at origin, and n poles at origin. So these are the standards given for body plot. So you have to remember only this table, okay, while drawing the body plot. So for constant k, that means your g of j omega into h of j omega is equal to k. At that time, slope is 0. This much you have to remember. Slope is 0. Then magnitude is equal to, you have to calculate magnitude. Magnitude is equal to 20 log of k to the base 10. And phase angle is equal to 0, right? So then 0 at origin. 0 at origin को क्या करना है आपको? You have to write only, replace s at s by j omega. So write j omega. Slope of that j omega is nothing but plus 20 dB per decade. Slope is always in dB per decade. So slope is equal to 20 dB per decade. And magnitude you can calculate by using this equation, 20 log of omega to the base 10. And you have to remember only phase angle is equal to 90 degree when 0 at origin is there in the transfer function. Okay. Then n number of zeros at origin. You have to write, you have to multiply with n, right? J omega into n. Then what is slope? Slope is again multiplied by n. So 20 into n number of zeros. Okay. Then magnitude you can calculate like this. 20 into n. You have to multiply by n only. Log of k. Log of omega to the base 10. Here, right? 20 into n log of omega to the base 10. Okay. And phase angle is 90 degree into number of poles. N is nothing but n zeros or not pole, huh? 0, 0. I am talking about 0. So n number of zeros at origin. So you have to multiply with that n number of zeros into 90. That is nothing but phase angle, right? So this is what about zeros. Now coming to poles. All zeros are present at the numerator, whereas poles are available at the denominator. Okay. So pole at origin. You have to write for pole 1 divided by s, that is 1 divided by j omega. Now in that case, slope you will get for pole, you will get slope is equal to minus 20 dB per decade. For pole, always remember slope is minus 20 dB per decade. Now calculating magnitude. Magnitude is calculated by using this equation, minus 20 log of omega to the base 10. Okay, to the base 10. So put the different values of omega in this equation, you will get magnitude in dB, right? Now coming to phase angle. So for pole at origin, phase angle is 90 degree with minus sign. That you have to remember. Phase angle is minus 90 degree, or you can write in other way, minus 90 degree is nothing but 270 degree, right? 270 degree. Okay. Now, next, nothing but number of poles at origin. So n poles at origin. So you have to multiply by n. 1 divided by j omega multiplied by n. So what is slope? Slope remains as it is, only you have to multiply by n number of poles. Okay. Minus 20 into number of poles, n number of poles. Okay. So you will get slope of that pole. Now, while calculating magnitude for n poles at origin, you have to use this equation, minus 20 into n into log of omega to the base 10, right? So just multiply by n number of poles. And what about phase angle? Phase angle remains as it is, minus 90 degree into number of poles. Okay. So n is equal to 4 असेल तर काय करायला लागेल? Multiply by 4. Okay, minus 90 degree multiply by 4. Like this, you will get phase angle, magnitude you can calculate, okay, and slope. For constant, this is the slope. Okay, this is magnitude and this is phase. For 0 at origin, this is the slope. You can calculate magnitude by using this equation. This is phase angle. For n number of zeros at origin, this is the equation for slope. This is the equation for magnitude, and this is the phase angle. For pole at origin, this is the slope in dB per decade with negative sign that you have to remember. When you are talking about poles, your slope is having minus sign, minus 20 dB per decade. This is the equation for magnitude, and this is nothing but your phase angle in degree for pole. N number of poles, so you will get slope just by multiplying number of poles. Okay, so minus 20 into, for example, 4. N is equal to 4. 4 poles at origin, so you are going to multiply with 4, right? This is the equation for magnitude in dB. Okay, multiply by n, and this is the equation for phase angle. Just multiply by n. So you have to remember this table. This is a very important table. Okay, related to Bode plot. Now you have studied related to constant. So for constant k, this is your magnitude plot, this is your phase or degree plot, phase plot. Okay, that you have studied yesterday. 0 at origin, this is your magnitude plot, and this is nothing but your phase plot that you have studied already. Then pole at origin, this is the magnitude plot, and this is nothing but phase plot. Then for real zeros, this is nothing but your magnitude plot, and this is nothing but your phase plot. Again, I am repeating for this. For real poles, consider open loop transfer function g of s into h of s is equal to 1 plus s into tau. This tau is nothing but time constant. Okay. So magnitude you can calculate, m is equal to 20 log of, बघा कसं काढायचं magnitude, under root of 1 square plus this term square. So omega square into tau square. So you will get magnitude in dB. Okay. Then phase angle, phi is equal to tan inverse of omega into tau divided by 1. You will get phase angle in degree, right? Now for the omega less than 1 divided by tau, omega less than 1 divided by tau, the magnitude is 0 dB. Okay. So when your omega, this value of omega is less than 1 by tau, that means up to this point, the magnitude is equal to 0 dB. The meaning is that the magnitude is equal to 0 dB. So you have drawn this line from 0 up to 1 divided by tau. Omega is equal to 1 divided by tau. Okay, the magnitude is 0 dB. So I have drawn this line. Okay, and phase angle is also 0 degree. And phase angle is also 0 degree. So I have drawn this 0 degree line from 0 to 1 divided by tau. Okay, first part. Now when this omega is greater than 1 divided by tau, that means after this, when this omega is equal to, or you can say greater than 1 by tau, that means omega greater than 1 by tau, omega greater than 1 by tau, the magnitude, this magnitude is nothing but 20 log of omega tau. Okay, so slope is nothing but 20 dB per decade, positive 20 dB per decade, okay, for real 0, right? After 1 by tau, omega t is equal to after 1 by tau, okay? So what is magnitude? Magnitude is 20 log omega t, omega tau dB. And what is phase angle? Phase angle is 90 degree for 0, right? So phase angle is changing from 0 to 90 degree, right? So phase angle is changing from 0 to 90 degree, okay? 20 dB per decade is the slope after 1 by tau, and after 1 by tau, your phase angle phi is nothing but changing from 0 to 90 degree, okay? Got my point? Now, this is the magnitude plot for real 0, and this is the phase plot for real 0. The same description is written over here, and this is nothing but your Bode diagram, or you can say Bode plot. Okay. The magnitude plot is having magnitude is equal to 0 dB up to omega is equal to 1 by tau. Just I have explained all these things. The same thing is written over here. Okay. So please go through this. Now, in this case, the phase plot is having phase angle of 0 degrees up to omega is equal to 1 divided by tau radian per second. And from here, that means from omega is equal to 1 by tau, it is having phase angle is equal to 90 degree. Now, this Bode plot is called as asymptotic Bode plot. Okay, so this is your magnitude plot. This is nothing but your magnitude plot, okay, and this one is nothing but your phase plot, and we are calling this plot Bode plot or Bode diagram as asymptotic Bode plot. So you have to remember this, okay. Now, any doubt up to this, student? Any doubt up to this? No doubt? Understood? Okay, thank you, Vita. Now let us see the rules. You have to remember this much only. Now give the heading. You have drawn magnitude plot and phase plot, right? For Bode diagram, okay? For given transfer function, open loop transfer function. When there are real zeros, when there are poles, when there are 0 at origin, when there is a constant, when 0 at origin, when then n number of zeros at origin, then pole at origin, and n number of poles at origin, and one more, that is real zeros. Okay, so now let us see the rules for construction of Bode plot. All should be here. Now follow these rules while constructing a Bode plot. Bode plot draw करताना आपल्याला काय करायचं, हे सगळे रूल फॉलो करायचे आहेत. So that you have to remember. I have explained all these things. Again, for your ready reference, I am going to explain all these rules for construction of Bode plot. Okay, chalo. Let us see one by one. So represent open loop transfer function. Represent the open loop transfer function in the standard time constant form. Okay, get the constant k. So what you have to do? You have to write your given open loop transfer function in the standard time constant form. So you are having with you standard time constant form, right? Now get the constant k, then substitute S is equal to j omega in frequency domain analysis. What you have to do? You have to substitute S is equal to j omega, right? In the above equation of open loop transfer function. Then calculate magnitude. So you'll get magnitude in dB. dB means decibel. So how to calculate magnitude? So magnitude is equal to, M is equal to 20 log of that constant to the base 10. Okay, then calculate phase angle phi. So how to calculate phase angle phi? phi is equal to tan inverse of imaginary part divided by real part, bracket complete. So you will get phase angle in degree, right? Then you have to find the corner frequency. So find the corner frequencies and arrange them in ascending order. Okay, then consider the starting frequency at the Bode plot as 1/10 of the minimum corner frequency, right? So consider the starting frequency of the Bode plot as 1/10 of the minimum corner frequency, or you can say we have started already. In last lecture, I have explained, I have started omega is equal to 0.1 radian per second. So same thing is given over here. Okay, whichever is smaller value that we have to consider. Okay, so 1/10 means 0.1 radian per second. So consider the starting frequency at omega is equal to 0.1 radian per second, or 1/10 of the minimum corner frequency. जो minimum corner frequency रहेगी, that is nothing but your omega, starting point of your frequency. So in semi-log paper, the minimum corner frequency is nothing but 0.1 radian per second. That is nothing but 1 divided by 10th of the minimum corner frequency. So always remember. So in last 4 examples, we have taken omega is equal to minimum omega t is equal to 0.1 radian per second, whichever is smaller value, and draw the Bode plot up to 10 times maximum corner frequency. What you have to draw? You have to draw the Bode plot up to 10 times maximum corner frequency. 0.1 into 10. कितना हुआ? 10 times maximum corner frequency. Maximum corner frequency जितना है, उसके 10 times आपको क्या करना है? Bode plot draw करना है. Got my point? Now, draw the magnitude plot for each term that is specified in the given open loop transfer function. So you have to draw the magnitude plot for each term. Okay, and combine these plots properly one by one. हे सगळे plot काय करायचे आपल्याला? Combine करायचे. And finally you will get Bode plots, complete Bode diagram. Okay, after combining all these plots properly, you will get complete Bode diagram or Bode plot. So draw the magnitude plot for each term and combine these plots properly, you will get complete Bode plot. Now draw the phase plots. Second plot कसा काढायचा? Draw the phase plots for each term. Each term means all the terms related given in the open loop transfer function. Okay, so draw the phase plot for each term and combine these plots properly. Okay, now note, the corner frequency is the frequency at which there is a change in the slope of the magnitude plot, is nothing but corner frequency. So student, you have to remember this. The corner frequency is the frequency at which there is a change in the slope of the magnitude plot, right? So these are some of the important rules while constructing the Bode plot. You have to remember. Okay, so please note all these things. Now, stability analysis. Small part is remaining only from unit 3. That is nothing but stability analysis using Bode plot. Bode plot वरून तुम्ही stability कशी decide करणार system ची. Okay, so stability analysis using Bode plot. Theoretical part है, but you have to remember this. Okay, question may ask based on this. So starting with this, from the Bode plot. Now student, all should be here. Please listen to me carefully. So stability analysis, please write important points only from the body plot. You can say whether the control system is stable or unstable or marginally stable based on the values of these parameters. Okay, so what are the parameters? Now these are the parameters. First parameter is nothing but phase crossover frequency. Phase crossover frequency, right? Second parameter is nothing but gain crossover frequency. As you have drawn magnitude plot, you have drawn phase plot. From that, you will get this parameter. Okay, phase crossover frequency. So what is this frequency? The frequency at which the phase plot is having the phase of minus 180 degree is known as phase crossover frequency. Okay, so remember this point. The frequency at which the phase plot is having the phase of minus 180 degree is known as phase crossover frequency. Now it is denoted by a letter omega suffix PC. Suffix say omega suffix PC. That is phase crossover. PC is phase crossover frequency. Okay, the unit of phase crossover frequency is radian per second. Okay, what is unit? Unit is radian per second. Okay, now second parameter is nothing but gain crossover frequency. So what is gain crossover frequency? The gain crossover frequency is the frequency at which the magnitude plot is having the magnitude of 0 dB. Okay, magnitude plot मध्ये magnitude किती हवंय? ज्यावेळेस magnitude 0 dB असेल is known as gain crossover frequency. Okay, when in magnitude plot, when your magnitude is 0 dB, at that frequency you are calling that gain crossover frequency. So please write these two definitions. Question may ask based on this in semester examination. So it is denoted by letter omega suffix GC. GC is nothing but crossover frequency. The unit for gain crossover frequency is radian per seconds. Okay. The stability of the control system based on the relation between the phase crossover frequency and gain crossover frequency is listed below. बघा आता आपण स्टॅबिलिटी कशावरनं ठरवतोय? स्टॅबिलिटी आपण ठरवणार आहे कशावरनं? फेज क्रॉसओव्हर फ्रिक्वेन्सी अँड गेन क्रॉसओव्हर फ्रिक्वेन्सी. So the stability of control system based on the relation between these two. Okay, now that is explained over here. If the phase crossover frequency omega phase crossover frequency, that is nothing but omega PC, is greater than the gain crossover frequency omega GC, then the control system is stable. काय आहे आपली केस? आपल्याला काय पाहिजे? ग्रेटर दॅन पाहिजे, राईट? काय ग्रेटर पाहिजे आपल्याला? ओमेगा फेज क्रॉसओव्हर पाहिजे. फेज क्रॉसओव्हर इज ग्रेटर दॅन काय पाहिजे आपल्याला? ओमेगा gain crossover. Gain crossover, right? Then you can say the system is stable in nature. So this is how you have to write. Okay, first condition, if this relation is satisfied, you have to find out first of all phase crossover frequency, then gain crossover frequency you have to find out from body plot. And if phase crossover frequency, this frequency phase crossover frequency is greater than gain crossover frequency, then at that time you can say the control system is stable in nature. Okay, आता second condition काय आहे बघा? If these two frequencies are equal, then the control system is marginally stable. That means if the phase crossover frequency is equal to gain crossover frequency, at that time your control system is marginally stable. So you have to remember this term. काय लिहायचं आपल्याला? दोन्ही पण फ्रिक्वेन्सी ज्यावेळेस इक्वल असतील, राईट, नॉट लाईक दॅट, यू हॅव टू राईट लाईक दिस, इज इक्वल टू ओमेगा GC. At that time you can say the system is marginally stable, right? सेकंड कंडिशन लक्षात राहिले. आता थर्ड कंडिशन काय आहे, ज्यावेळेस फेज क्रॉसओव्हर फ्रिक्वेन्सीची व्हॅल्यू इज लेस दॅन काय म्हणतो आपण गेन क्रॉसओव्हर फ्रिक्वेन्सी. ऍट दॅट टाइम युअर कंट्रोल सिस्टम इज अनस्टेबल इन नेचर. So the third condition you have to remember related to this, the phase crossover frequency is less than the gain crossover frequency. At that time your control system is unstable. So third condition you are going to remember, that is nothing but omega PC, right? Omega PC काय आहे, less than omega GC, right? At that time the system is unstable. Okay, so these three conditions you have to remember. Got my point? Just remember these three conditions related to stability. So from Bode diagram, from Bode plot, you will get the value of phase crossover frequency, you will get value of gain crossover frequency. Just I have given you the definition how to calculate from diagram, Bode diagram. Okay, now just comparing these two values you will get stability of system. Now when this phase crossover frequency is greater than gain crossover frequency, your system, control system under consideration is stable. Second condition you have to remember, when both are equal, phase crossover and gain crossover जर equal असेल, the system, control system is marginally stable. थर्ड कंडिशन काय लक्षात ठेवायची तुम्हाला, when phase crossover is less than gain crossover frequency. At that time your system, control system is unstable in nature. Finished. Got my point? Any doubt? Students, any doubt up to this? No doubt. बरं ठीक आहे. आता गेन मार्जिन आणि फेज मार्जिन काढायचं आपल्याला. So how to get that gain margin and phase margin? For that you have to remember one equation. That equation is given over here. Okay, this is the equation for gain margin and this is the equation for phase margin. Okay, now please write down these two equations. So gain margin is denoted by this letter GM is equal to negative of the magnitude in dB, okay, at phase crossover frequency. So GM, gain margin, is equal to 20 log of 1. हे काय आहे, magnitude in dB at phase crossover. Okay, magnitude in dB at phase crossover frequency. M is magnitude in dB at phase crossover frequency. Okay, so this is the equation for gain margin is equal to 20 log of MPC, that is nothing but magnitude of phase crossover frequency at phase crossover frequency. Okay, that value you have to take over here, you will get gain margin. So student, please write this equation for gain margin. This is the equation for gain margin. 20 log of MPC, magnitude in dB at phase crossover frequency. Okay, that you will get from graph plot. Now where this MPC is the magnitude at phase crossover frequency, the unit of gain margin is in dB. 20 log of घेतोय म्हणजेच काय आलं, in dB. Okay, आता phase margin हे झालं gain margin. Second important point काय आहे आपला, phase margin. So this is the equation for phase margin. Okay, so student, please write this equation. The formula for phase margin MP is equal to 180 degree. This is degree, 180 degree raised to आहे plus 5 GC. So what is 5 GC? That is nothing but phase angle at gain crossover frequency. लक्षात येत आहे, आणि फेज अँगलचे युनिट काय असतं, डिग्री. ओके, So you have to remember, student, please write this equation. This is the equation for phase margin. Phase margin is equal to 180 degree, 0 नहीं है वरती गया, 180 degree थोड़ा हे झालेलं इथे मिस्टेक आहे, 180 degree plus 5 GC. What is GC? GC is nothing but gain crossover frequency. So where GC, 5 GC is the phase angle at gain crossover frequency. The unit for phase margin is in degree. Okay, got my point? So please write this equation for gain margin, this equation for phase margin. Now from this, again you can comment on stability. The stability of the control system based on the relation between gain margin and phase margin. That conditions are listed over here. So if, again 3 conditions similar to your last slide, you will get 3 conditions over here that is related to gain margin and phase margin. Just in previous slide you have compared, yes, phase crossover frequency and yes, gain crossover frequency, right? And depending on the relation between these two, phase crossover and gain crossover, you have concluded about the stability of system. Similarly, depending on gain margin and phase margin, you can decide the stability of system. Now let us see what are the conditions, okay, depending on phase margin and gain margin. Now if both the gain margin and phase margin are positive, then the control system is stable in nature. If you got both the values, both gain margin GM and phase margin PM are positive, then control system is stable. Control system under consideration is stable, said to be stable. Okay, first condition, that means you can write like this for remembering this: gain margin and is equal to phase margin and is having positive value. At that time, your system is stable. Okay, so remember this condition. Then second condition, if gain margin and phase margins are equal to 0, at that time, your control system is marginally stable. Now, when this GM is equal to PM, that is gain margin is equal to what you call phase margin, both are 0 equal to 0, then your system is, yes, system is marginally stable. Okay. Third condition you have to remember, that is if gain margin and or the phase margin are or is negative, anyone is negative at that time, anyone, जर तुमचं GM negative असेल, GM negative असेल and or PM negative असेल, PM negative असेल, anyone, if gain margin and phase margins are negative or gain margin negative असेल किंवा phase margin negative असेल, at that time your system is, yes, system is unstable, right? So these 3 conditions you have to remember. Again, I am repeating in short, when both gain margin and phase margins are having positive value, at that time your system, control system under consideration is stable system, you can say. Okay. Second condition you have to remember, that is when both gain margin and phase margin are equal to 0, हे दोन्ही इक्वल टू 0 असेल at that time, your control system under consideration is said to be marginally stable. Third condition you have to remember related to phase and what you call gain margin and phase margin. At that time, if anyone is negative or both are negative, if gain margin is negative or phase margin is negative or both are negative, at that time your system under consideration, that is control system under consideration, is unstable in nature. So these three conditions you have to remember. Now this is nothing but related to stability of your control system from Bode plot. Understood? Any doubt up to this? Any doubt, students? Understood? Chat box मध्ये लिहिले understood. Okay. Understood clearly, madam. Please note down all three conditions related to gain margin and phase margin, and three more conditions related to crossover frequency, right? Phase and gain. So with this, student, unit 3 is completed. Any doubt, students? Please study hard for in-semester examination. In-semester examination is on 7th March. No doubt, madam. Thank you, ma'am. Thank you for your feedback. So student, if you are not having any doubt, please write your attendance with understanding in chat box. Then you are free to move. Thank you all.